This lesson on piecewise functions should have already got an introduction to that in our class. If not, you might want to watch that video from Tuesday, September 8th. Should have been your introduction to piecewise functions. Your assignment for piecewise functions is going to be in Delta Math, so I figured for the video I would just do a few of those sample problems for you. So let's say we have this piecewise function and we want to find f of 1. So with piecewise functions, you actually want to look at them kind of right to left. You want to look at the inequality first and then look at the different rules here. So we want to see which one of these three things x equals 1 satisfies. So f of 1 means x equals 1. So we go over here. 1 is not greater than 3. 1 is not equal to 3. 1 is less than 3. So x equals 1 satisfies this part right here. And so that means that we're going to use this rule here. So we're going to have negative 1 minus 2 squared minus 3. So that's negative 1. I should probably write this out because there's a few negatives flying around that might give some people some trouble here. So make sure you can't do change with those negatives right there, right? Those negatives can't cancel each other out. You've got to do the exponent first. And so negative 1 squared, negative 1 times negative 1, that's positive 1. And then we stick the negative on it. So this is negative 1 minus 3. And so our answer right here is going to be negative 4. Submit the answer, and we've got that one right. Okay, so another one of these, let's say we want f of negative 4. So we look at these rules right here. Now, negative 4 is one of the places where it switches rules. So less than negative 4, we use this rule. Greater than negative 4, we use this rule. And then, well, what about when x equals negative 4? Well, that's where we've got to look at which one of these has the or equal to it. This one has the or equal to right here. This is where we're allowed to equal negative 4. So we use this rule for x equals negative 4. So we would say negative 4 plus 3. Just replace x with negative 4 once we've selected the rule in this one right here. And so of course that's 4 plus 3. So the answer is 7. Okay. One more of these right here. So if we want f of 3, we want x equals 3. But notice both of these are strict inequalities. Here we can only be less than 3. Here 3 has to be less than x. That means x has to be greater than 3. Neither of these allows us to have x actually equaling 3. So it turns out for this one, there actually is no function value. There's no point on the graph for x equals 3. When that happens, they're going to have a button for you right here. You just click the button for undefined, and then you can submit the answer. And we've got that one. Okay, so that's evaluating or finding function values. So now what about graphing? Okay, so let's say we want to graph this. It's one function with two different pieces. So for x's that are less than negative 4, we use this line. For x's that are greater than negative 1, we use this line. And then looks like there'll be a little bit of a gap in the middle. There'll be places where it's not defined at all. Okay, so what we want to do is we want to figure out that these x values, those are the key places. You've got to figure out what's going on at those spots. Okay, so what we do, even though it's supposed to just be x is less than negative 4, we're still going to figure out what's happening there because we're going to have an open circle at this point right here. Okay, so I'm going to find negative 3 times negative 4 minus 8. So 12 minus 8. So that's 4. So that tells me I'm going to have negative 4 comma 4 as the starting or stopping point for this piece of the piecewise function. Okay, because there's no line under it, it's going to be an open circle. If there's a line under it, it would start or end at a closed circle. But either way, I've got to take this x value, plug it in here to find out that key point. Okay, so what I'm going to have it negative 4, 4 right here. I'm going to have is where the line starts. Okay, or stops. And then I want x's that are less than negative 4. So I'm clicking and holding I click and hold, and then I move around, and it allows me to move where this other point is. So I clicked, and I'm holding down, and I move this around here, okay? And I don't want it on this side. This would be x's that were greater than -4. I want x's that are less than -4. So I want on the left side here, and I just have to figure out where this next point should go. Well, I know that the slope is -3. If you look at that rule right there, -3x minus 8, mx plus b, the slope is -3. So if the slope is negative, I need a downhill line like this. Okay, and so normally you would go down 3 and right 1, but that's the wrong direction. We want to go to the left. So instead of going down 3 and right 1, I can go up 3 and left 1. And now I've got that correct slope that goes down 3, right 1 to get to that point there. Okay. And so then now that I've got this second point, now I can let go. This whole time I've been holding down on my mouse or on the button on your trackpad. I've been holding it down the entire time and moving this around. And then I can just now finally let go. Okay, and then see these notes here. So we click on an endpoint of a line to change it. Okay, so this point right here at -4, because there's no line under it, because it's strictly less than -4, that has to be an open circle. And then this is supposed to go on forever for all the x's that are less than -4 going on forever. So I click this endpoint. First, it'll give me an open circle. And then if I click it again, it'll change into an arrow. And so this is what I want for that section of the graph. Okay. Now for the other one here, I'm going to want x is greater than -1. Let me just show you this clicking the line to delete it. Let's say you make a mistake. Let's say I put that in there randomly, and then I'm like, wait, no, that's not right at all. To get rid of something, you just go in the middle of the line. It'll give you that symbol there, a circle with a slash through it. If you click right there, it'll get rid of it. Okay. All right. So again, because even though it says x is greater than -1, even though I'm not supposed to use x equals -1 in this rule, I have to still plug it in. I have to still do -6 times -1 plus 1. 6 plus 1 is 7. So that's the point, -1 comma 7. So I'm going to be up here. Okay. It'll be an open circle. It's not actually a point for this function, but it's still where I have to get started. Okay, so I'm going to click and hold so that I can drag this around. And then, so you got two options here. One option is, the slope is -6. So you could count down 6 and over 1. Or we know that the y-intercept is 1. So you could just go over straight to the y-intercept of 1. And that's the right direction. We want x is greater than -1. X is less than -1 would be this side. You never want overlap like this. It's got to be a function, so it's got to pass the vertical line test, right? So never let it overlap like this. We didn't want x is less than -1. We want x greater than -1. And so I can include this y-intercept right here. And then because it's a strict inequality, I change that to an open circle, and then I want it to go on forever. So I click that until it turns into an arrow, and then I can submit my answer, and we got it right. Okay. So now let's try one that has 3 different pieces here. Now, one thing just to point out, if you're ever not sure what you're doing, there's a link right here that says Watch Help Video. You can always click this, and they've got some more examples for you. Okay. All right, so let's take a look at this. So this section right here, I'm going to figure out what's going on at 2. So I'm going to say -5/2 times 2 plus 3. So the 2's will cancel out. So I'll have -5 plus 3, -2. And so I've got 2, -2 is the point right here. So 2 and -2, I'm going to click and hold down so that I can move this other point around. And then I want x's that are less than 2, so I want this direction, not that direction. And so if I'm going this direction, it includes the y-axis. So instead of using the slope, I can just go right to the y-intercept right there. That plus 3, let's just use the y-intercept. And then this one, because it is the or equal to right there, I can go ahead and leave this as a closed circle right there. And then the less than 2 is supposed to continue on this direction. So let's click this point, keep clicking it until it changes to an arrow. Just click it twice. All right, so there's that section. Now this middle line, we have two key points we have to figure out now. We have to figure out where it starts and where it stops. All right, so I'm going to use x equals 2. So 2 times 2 minus 6. 4 minus 6, that's negative 2. So it's going to start at the point 2, negative 2. And then, let's see, it looks like this froze for a second, okay? And then we need to plug in 7. So we need to have 2 times 7 minus 6, 14 minus, let's see, 2 times 7, sorry. 2 times 7, 14 minus 6, that's 8. So it's going to stop at the point 7, 8, okay? So now notice I already had a point at 2, negative 2. I'll have to talk about that in a second. For right now, it doesn't matter too much. I can just click right there at 2, negative 2, and then I'll go and find 7 and 8. Okay, so again, click and hold and drag over to 7, 8, and then let go. Okay, all right, so at 7, it's a strict inequality, so no or equal to, so let's change that to an open circle. Now at 2, we would do the same thing. We would normally change this point to an open circle. The thing is, we already had a point there. We already had a closed circle. So this one says what we did before. This one said a closed circle at 2, negative 2. And this one says an open circle at 2, negative 2. Well, which one wins? If one says a closed, one says an open, which one wins? What do you think? It is going to be the closed circle. The closed circle fills in the open circle. An open circle is just a lack of a point. It's just saying that you're missing that point, that number. You don't have that number. So, well, this one's missing it, but this one does have it. So it just kind of fills in. Okay. All right, now what about this one? This one just has negative 6. There's no x there for this third rule right here. So if I try to take 7 and plug it in, there's no x. What this is, so f of x equals negative 6 is what we're looking at right here. Well, that's the same thing as y equals negative 6. That's a horizontal line. If you look at this, this is the rule where it doesn't matter what x is. X can be 7, 8, 100, 3. Regardless, there's no x right here, so you're always getting negative 6, negative 6. It's a constant function. So I'm going to go over to 7, and I'm going to have negative 6. Make sure I get this lined up correctly. And then I wanted x to be greater than or equal to 7. So I start here, greater than, it's the right side. I want to go in this direction right here. Again, if I went that direction, I would know it was wrong because there would be overlap. Let me just show you this here. If there was overlap, this would fail the vertical line test. So it would not be a function. And so it can't be this direction. I can't have that overlap failing the vertical line test not being a function. So let's delete that. Let's make sure we go the right direction. Go to that side right there. It was or equal to, so I'll keep that a closed circle. And then I just need to click that twice to change it to an arrow. And we can submit our answer. And we got it right. Okay. So now, what if they're not just lines? So if they're not just lines, they're going to give you a different system for how to do it. Okay, let me do the bottom one first to really show you this. So absolute value, we know that absolute value is going to be a V shape. So we're going to click this V shape, and it'll put a V shape on the graph. And then we move the blue dot to where the vertex should be. So we know that x minus 4 goes with x equals 4. It's a shift right 4. So I'm going to move it right 4. And then the minus 3 shifts it down 3. If I plug in x equals 4, I get negative 3. So the vertex should be down there. Okay, so if we only had f of x equals absolute value x minus 4 minus 3, that would be the whole graph. But then we need to cut it off. We need to only have x's that are greater than 3. So once you've got the shape of the graph in the right place, then you can click done. And then it's going to give you these blue arrows you can drag to cut off the graph. So I don't want negative x's. I don't want x is 0. I don't want x is 1, x is 2. It has to be x is greater than 3. It has to be 3 and bigger numbers right here. Numbers bigger than 3 for x, okay? I don't need to drag that side right there because it is supposed to go on forever here. X is greater than 3 forever over there. And so then I can click done. And then just because it was a strict inequality, I changed that closed circle to an open circle. For the line right here, so it's a line with a negative slope, so I'll click the downhill line, and then the y-intercept is 0, so I can leave it right there. If there's like a +2, if there was a +2, then I would drag it up to a y-intercept of 2, but there's no number there for the y-intercept. The y-intercept is 0, so I can leave it right there, and then click done, and then I just need to cut it off. So this one I need to drag the right side. I can't have that overlap that's making it not be a function right now. I want x is less than 3, so I have to cut this off right here. Okay. I only want this side of the graph where x is less than 3. Then I can click finished, and because it's a strict inequality, I will change that to an open circle. If you ever need to, you could start over. Let's submit our answer, and we're good on that one. All right, so do one more of these. So the absolute value here is a V shape, and the -1 is going to shift it down 1. And then we hit done. So again, we hit the shape, and then we move the shape, and then we hit done. And then we drag the arrows to match this inequality here. So this one's supposed to be in the middle of -3 and 1. So it has to start at -3, and it has to stop at 1. And then we click done, and they're strict inequalities, so we change them to closed circles. And then for the second part here, the square root graph, we know is this kind of swoosh shape here. So put that there. X minus 1 goes with x equals 1. We're over on the right side right there. And then we can click done. And then we need to be between 1 and 5. So we drag the left side over to 1 and the right side over to 5. And then we click finished. And then at x is 1, it's an open circle. This one, both of them are open circles. Both of them are strict inequalities at x equals 1. So I do change that to an open circle. And then the 5 right there, that one, it can be or equal to, so I do have the closed circle. I can submit my answer, and that one looks good. So just one more here. What if we want to go backwards? Going backwards. What if I give you the graph and we want the rule? Okay. Well, let's start with the inequalities. The inequalities will be a little bit easier. Okay. So let's start with this piece right here. So this one, so we'll put the x, and then this section right here, we're starting at -1, and then we have all the numbers bigger than that. So we're going to say x is greater than -1 is the inequality for this section here. And then for this section here, well, we want all these numbers -4 going on to the left. Because it's a closed circle, we need the or equal to. There's buttons for that. If you look down here, we've got the less than or equal to button right there. So less than or equal to -4. And then here is where we need the mx plus b. So both of these parts are going to be some sort of mx plus b that you've got to figure out. Okay, so for the first one, let's see, we can count the slope here. It goes up 1, 2, 3, 4 over 1. So our slope is 4x. Both of these are uphill lines with a positive slope. And then this one's easier. You can see the y-intercept right there. You can see that it crosses at 8. So 4x plus 8. Okay. For this one here, so it looks like it's just going up 1 over 1, up 1 over 1. So it looks like our slope is 1. So we can just say x. You could say 1x if you want, of course. Let's say x. Okay. And then you've got a choice. So one thing is that if it's got a nice slope like that where it'll have a nice y-intercept, you could kind of keep counting up and over until you get to the y-intercept to figure out this. You could solve it algebraically, of course. You could look at this and you could say, all right, I've got a point at -4, 1. And then I've got this point at negative 5, 0. If you weren't sure about the slope, you could find the slope right there if you wanted to, y minus y over x minus x. You could solve for b here. You could say, all right, I've got y equals x plus b. Plug in one of these points right here. 1 equals negative 4 plus b. And so b equals 5. You can always solve these algebraically, or again, just count. If I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, there we go. We're at 5 right there. So it's x plus 5. Submit the answer, and we're good to go. And then don't forget, if you want more examples, the Delta Math has these watch help video links that you can click.